Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. We have a special guest here today, David from the Technophiles podcast. Welcome, David.
Ben, thank you so much for having me.
No problem. So I hear you have a problem or something you'd like to fix with a certain classic game console?
Well, it's true. I was actually able to get my hands on a NES Mini.
I've never even seen one of these in person before.
Well, yeah, here it is. This is the box. It's technically the NES Classic Edition, but
really exists.
Everyone's calling it the NES Mini. Very hard to find. I was
Awesome.
lucky to be in the right place at the right time.
Well, that makes sense.
So, you know, one thing though that is, it's a lot of fun to play games on this thing, but a lot of people are also noticing that the cord itself, the cord from the controller to the console, is very, 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 very short.
Oh yeah, I've heard about that on YouTube. Well, maybe we could take a look at extending it. So I can show you and our audience how you can extend a cord like that. And we can use the oscilloscope to look at the signals to make sure everything's working properly before and after. So let's do this. Let's do an unboxing, then we'll take it apart, see what's inside of the NES Classic, and then we'll extend the controller cable. Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
The first thing we did was unbox the NES Mini. We found some manuals, a sweet retro poster, some power and HDMI cords, the controller, and of course, the unit itself. Pretty standard stuff. Now, let's take it apart. I think it's time to take this thing apart.
Sounds good, Ben. I have very complicated emotions right now because it's cool. I'm so excited to be here, and I'm so excited you're going to be taking this apart, and I really want to see what's inside, but at the same time, it's a little scary,
It'll
you know?
be fine.
I trust you. So what do we have here? Just regular old screws here, huh?
Yeah, they must not care if you know what's inside of this controller. I think it'd be cool to compare the inside of this controller with the Wii controller you have.
I'm up for it.
Oh, look, they have the same strain relief as they did in the past. WCP. Oh, look at all the 0 ohm resistors.
I don't even know what those are, Ben.
Well, they're just resistors they're just jumpers.
Oh yeah?
0 ohm resistors, so there's no resistance. See, because it's single-sided PCB.
Oh, right.
To save money, so in order to go across contacts, they just put a part in its place. See how there's connections
like
going
a little
under
bridge.
it?
Yeah, sure, yeah.
See these big, thick traces? So you can have power, ground, and then you're gonna have, well, it's I2C, so you can have serial data and serial clock. So we'll actually be able to look at the signals using that oscilloscope.
Cool.
So what I'd like to see first, I often do this, I start with the controller, and then I go work my way in, is, yeah, I'm kind of wondering what would be in this thing, if it'll be the same.
Right.
That's what I'd like to check first. Oh no, your tri-wing, tri-force screws cannot stop me. That's my impression of Tommy Wiseau taking apart a Nintendo.
That's good.
Ha ha ha. Oh no, it's too deep for my screwdriver. I have another. Ha 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 ha. I would do anything for my Lisa. Ha ha ha. Oh, I can reach screw now.
Tricky, huh?
Yeah, it's not wanting to play ball. I think we need to send this controller to the doctor. To Dr. Mario. Do you think Dr. Mario really went to medical school?
I doubt it.
All he does is throw pills in a jar.
In a reckless manner, frankly.
He's kind of like the Walter White of the video game world.
From humble plumber to drug lord. Okay, we got a little bit more going on here.
Well, it looks like it's the same chip.
Yeah?
Dun, dun, dun.
Oh, yeah.
In a shock to no one. Okay, yeah, so your Wii controller, the chip was manufactured the 34th week of 2009. That sound about right when you bought it?
2009? Yeah, maybe.
Oh, I'm like one of those like fake psychics. There was a death in your family.
I could tell by the essence of the controller that you purchased it around 2009.
I'm hearing it's about the money.
Yeah, you know, I think that feels right. I think he's right. I've had conflicted emotions about this controller.
I'm sensing a male figure or maybe female.
Yeah, he's right. It was one of those.
Yeah, it's the same chip. WCP405. The only difference is the date code. See how all these pins are attached there? See those connections?
I do.
And they don't have it here.
Oh yeah.
So yeah, you could wire stuff up to this and turn it into a Pro Controller.
Wow.
Oh, here's my surprise face. Well, shall we do a teardown of this?
Let's do it.
All right, so looks like why is this screw separate? That's what I want.
And that's the only visible one right now.
They're probably under the feet, if I had to guess. Oh yeah, look, there's something under these feet. Usually you go for the feet or the warranty void if removed sticker. Oh, they're just regular Phillips screws.
Wow, Nintendo's getting lazy.
Yeah, they just don't care anymore. They're like, oh, please don't look inside and find an ARM chip. All right. Well,
Interesting.
We're in like Flynn. Okay, well, this looks like the controller here. Let's just count this. Power, ground, and then 2 I2C.
Is this also the other controller, or is that something different?
Oh, you're right. I didn't even see that, sorry. I wonder why they have so many pins. Yeah, see, I mean, if you look at it, there's like 6 wires there, but there's just 4 wires there. They might have a bunch of extra grounds.
Yeah, you're right. See, you know,
6?
I don't really know what I'm talking about, but I feel like it'd be really easy for them to just steal the thing that goes in the back of the Wiimote and put it right in here.
That's probably what they did. Yeah, it just looks like 5. That's weird that they have extra wires.
Well, that's handy.
Yeah, there we go. Little bitty buttons. Whoop. See, it's a
Look at that.
on-off switch and then just a little tack button right there. See, that's the kind of button, if they wanted to have a shoulder button on the controller, they'd have to have a right angle tack switch like that.
I see.
But, you know, actually tack switches, they're not super cheap.
I'm noticing this one has a spring around it. Is that for any particular reason?
Make it feel good.
Okay. That Nintendo reset button feels so good.
Looks like all these screws are the same. That makes sense. RFC. Oh, looks like it might have a little bit of a heat sink going there.
Oh,
it's probably
right.
gonna be, yeah, there's probably gonna be a thermal pad. So, you know, if they have a thermal pad on this thing, it's probably not too slow of a system. Oh yeah, see how the HDMI isn't upside down. It's just mounted on the bottom of the board.
Oh, wow.
See?
Yeah, I do see that.
Well, you know, they'll figure out, okay, the board plane is here, so that means, you know, such and such components are here and here. Like, if I don't know if you've ever seen, like, sometimes if you get like a memory card reader, like a really cheap one for your computer, some of the cards will stick in upside down.
I have noticed that, yeah.
And that's because they mount the ports above and below the PCB. So this should come out now. There we go. Let's just look at the base unit.
Yeah, yeah.
Oh yeah, so yep, see there's 2 individual pieces like we thought. And this is probably, yep, that's holding them in.
Cool.
So that just kind of makes them one. So we could actually put that screw in right now.
I see.
All right, well it's got, well let's look at the back of it first before we take off the, well this is obviously where the system on a chip is. You can see the all the power connections below it. Just like the underside of any CPU.
I see that, yeah.
So to recap, we have an ARM processor, 256 megabytes of RAM, 512 megabytes of flash storage memory, and a power management chip. On the back, a chip that takes parallel RGB image data and turns it into LVDS differential signaling for HDMI, and that's it. Pretty cool. Next, we want to try to figure out the controllers, huh? I thought it might be cool. I hooked up a header here so we could see if there's any signals on that pin that look like a header pin.
Right.
I just want to see what happens. See that? That's a data packet.
Yeah.
See, there's a command being sent, that first byte.
That's what that is.
And then there's a response. If there's bus decoding on this, we might be able to actually see the data. The scope can like sniff it. The one on the top, those are clock pulses, and the one on the bottom is the data. So I wonder if we can, let's see, do we have bus analysis on this? Oh, here we go, serial bus, yes. Mode, I2C, signals, serial clock. Oh, does that say 2 on it?
Yeah, I see it too.
Okay, yeah, so that's the clock, and then number 1 is data. So here's my feedback. I'm kind of colorblind, so is Max, and those are 2 different colors, apparently.
Yeah, we got yellow and green.
Yeah, but I can barely tell.
Got it.
Serial clock, okay, so we have to switch this around. So the clock will be on the 2nd channel. So what we can do is we can use the oscilloscope to read the bus. Serial clock on channel 2, serial data on channel 1. See, now it's assigning hex. See that?
I do see that.
It's decoding it in real time. So we can back out like this, and we can stop it, and then we can see what all the data is in the packet. See that?
And this is data coming out of one of the chips right now? Or?
It's coming out of the controller.
Got it.
The main system is saying, hey, controller, give me your status. See how when we zoom out, it's kind of compressing the data, but there's actually a lot more data than just that.
Oh, I do see that, yes.
Yeah.
Is that from me wiggling all of that feedback?
No.
Okay.
No, that's just because we're looking at it at a very high speed.
David, that's just because your hand is cramping.
But we should, if we move this around, we should see some of the numbers change. All right, let me know if I erase any of your save states.
Right.
Oh yeah, see how, so that particular byte is the up-down pad. See how it's changing?
I do see that.
Well, actually, if you look at, do you know anything about hexadecimal?
Only just a little bit from like graphic design and stuff.
Okay, well, in hexadecimal, it's 8 bits in a byte. In hexadecimal, there's like 2 characters, it's 0 to 9 and then A through F. So FF represents the top and the bottom pairs of 4 bits, and 4 bits is a nipple. So if we have this up, down, left, right joystick, that's 4 bits of information. It's either on or off.
Right.
So what happens is It's normally all high, that's why it's FF, that's 8 ones. But then see how the joypad, see how it only affects the character on the left?
Yes, I do.
See the B?
7.
Right, so it's only affecting the top 4 bits of that particular byte. The lower bits are probably something else like the buttons, although I can't really hit that without messing up anything. Yeah, so this is definitely an I2C bus. I think we could extend this cord without too much difficulty.
That's cool. And you know, Ben, the classic controller over there for the Wii, the analog, the left analog stick does work on games on this system. Is that maybe where some of that extra, you know, data is that you're seeing there? Like,
yeah, the numbers that aren't changing, that's because there's just nothing on this system. They're probably just locked at a certain value or locked it off. What we can do is we can actually, we can stop this and we can zoom in and look at a little bit more of the granularity to it. Yeah, so this is the command sequence where it's saying wake up and then it's giving you the command. So this is coming from the ARM chip. And then this is the response from the controller. And so yeah, with the scope, we can see the hex value of everything. So here's like 0, 0. See how 0, 0 is all low?
Right.
And then FF is all high?
Totally.
So it's all zeros, all ones. Oh yeah. This is something we might need to think about. See, there's a little bit of variation on the spikes there. That can happen from the chords.
Interesting.
We should be all right though. So yeah, look at, there's like at least 4 of these that are, actually 5 of these are 0, 0.
I see that.
So those are probably just functions that aren't even hooked up. You know, like things that would be used on the Wii control, the Wii Classic controller.
Right.
Actually, we could hook up that controller and look at the difference.
Take a peek?
Yeah,
Oh, yeah, definitely let's do that because we don't. That's easy to do right now, isn't
Yeah,
it?
as long as just hold your hand really steady there, okay? All right, now we should see, I'm gonna guess probably those 2 numbers there. See the 8584?
I do.
They're not exactly the same, that's probably why they're analog. I'm gonna guess.
Oh, look at
that. Those are gonna change.
That's cool.
Well, there's gonna be 2 bytes for each one. There's gonna be left, Y, X. See, so that's left vertical, left horizontal, and then right vertical, right horizontal. So they're actually staggered. So those 2 are your left stick and those 2 are your right stick. And then your analog buttons are probably gonna...
Anything?
There they are, right there.
Yeah, there they are, yeah.
Yeah, and then the D-pad would be in the same place as before. Cool.
That's cool to see, yeah.
Yeah, so that's how the I2C bus works. It's I2C, from what I understand, it's meant to be used on a system. It's not necessarily supposed to be used with wires. The cord might not be short just to make people mad. It might be short for engineering purposes. All right, now we're going to look into extending this controller cable. Now we saw that these plugs have like 6 wires on them, but if you look at this end, it's only using 4 wires. See that?
Now does that come right out or are those hardwired in there?
That's hardwired in.
Okay.
That's not a plug, because a plug would cost
money!
That's correct! We need to figure out which one's ground. Well, actually, it's fairly obvious. Yeah, see how this one goes to all the traces?
I do, yeah.
That's gonna be ground, and the other one's gonna be power. But you know what, I'm gonna double check before we do anything.
Yeah,
just
cool.
to make sure. Oh yeah, you can also see there's a pull-up resistor here going to the data lines. That's how you can tell it's power. Okay, so what I'm thinking we could do is we could use this Xbox One cable.
Sure.
Like if you buy an Xbox One controller for PC, it comes with this like really long cable. Look at that.
Why do you think it does that?
I don't know. Oh, maybe it's so you can use it with your PC if you don't have a wireless dongle.
Yeah, actually maybe.
Yeah.
You could just use it as the game cord, huh?
Yeah.
Right.
I mean, you can get a wireless dongle to use those controllers with your computer. Although the Xbox One controller dongle only works in Windows 10.
Wow.
Lame. No, don't do it. Ah, let them eat cake. Now you asked about that plug that was on here. What we could do is we could wire directly to that. That way we don't have to like rewire it twice.
Right.
Because otherwise we'd have to splice it and then splice two ends.
Right.
But if we cut it here and then spliced it once and then solder the other side directly to this, that should work. So what I'm gonna do is I'm gonna mark this so we know what its polarity was. Oh look, that's a 5-pin and they're using it as a 4.
I noticed that.
Yeah, and again, they made mad money off of this. Check it out. We have 4 wires.
There it is.
5 if you count ground, but we'll just tie the grounds together. That will help with interference. But I'm curious to see if we see different shapes on the waveform of the scope. That's why I saved it to SD card or thumbstick, just so we could compare. But if we do see a difference, that might shine some light on why Nintendo wanted to be very conservative with the cord length, because the longer the cord is, well, it starts to become like an antenna. What I'm gonna do here is I'm gonna get both of these ends disconnected. So I'm thinking this end we'll put near the console.
Okay.
Oh, you know what else you could do? You could make your own controller using like an Arduino or something. Just respond to the signals the same way.
Is it conceivable to take an original controller and map it to this?
Well, you'd have to have the right circuit inside of it. But
Yeah, oh, right, of course.
But yeah, there's no reason you couldn't put that chip inside an original controller, or just figure out what the, you know, the protocol that we saw, figure out what it is, and then just basically spoof it. Like just, you can make a microcontroller that says, oh yeah, you're asking for such and such, well here's such and such back. So what I'm thinking we do is we wire this directly to the controller.
Yeah.
And then we wire this, we split that into here.
Sounds good to me.
Yeah. Now if we want to be really fancy, I can take my X-Acto knife and scrape off a little bit of this solder mask. That way we can solder it even tighter. It's like strain relief of the strain relief of the strain relief. All right, so I'm just gonna arbitrarily, well, red I'm gonna use for power, these are the ones. So these are the USB colors.
Right.
White and green. Let me get my auto strippers. They're like robotic teeth. Okay, so before I put these through, I'm gonna tin them, which means to put a little bit of solder on them. The reason I'm doing that is because the tips might be a little frayed.
Oh.
And as you push it through, some of the strands might not go through, it might stay on the back and then short circuit.
Oh.
So by tinning them, you ensure that they all go through.
It's like when campers melt their ropes a little bit or something.
That's yeah, good analogy. I brought them through all the way just to make sure that none of the metal can touch on this side. Bring it all on this side, and I'm gonna pull them taut in this direction. I'm not gonna scrape the copper in this case. I'm gonna pull them taut like that.
Yeah.
Then I'm just gonna hit them with a little solder from behind, like that. Happy little clouds. Now I can cut them short, just so they don't short out. As long as I do this here, it won't cut the trace. It actually takes quite a bit of force to cut a trace.
Oh yeah?
Yeah.
You
so,
say here compared
well,
to like...
Yeah, where I just cut, it's like, oh no, he's gonna cut the traces.
Right.
But no. It's like one of those things, like if you try to cut a trace, you're like, wow, this is really difficult to do. Therefore, I do not have to worry about doing it accidentally.
I see. Is that because there's a couple extra layers of stuff on there and stuff?
Well, there's like the solder mask. And,
right.
I mean, to really cut a trace, you have to almost dig into the PCB. A much bigger danger is like accidentally, like if you tried to like remove one of these resistors, like the metal under it, like the pad, the area of copper that connects to the resistor,
yeah.
That lifting up is actually a much bigger danger than just randomly cutting traces. You know what? It probably would not hurt to put some hot glue on this.
Yeah.
Just before we close it up. So we've got, yeah, we soldered it really good. We put on the strain relief, we put on the tape, and then we'll put some hot glue on it just to make darn sure. Next, we have to splice these wires together. Okay, so there's a trick I like to do when I'm splicing wires. I like to do it at multiple lengths.
Oh, right.
Because then they tie together better. Yeah, I just realized another challenge with this though. We have this heat shrink tubing to make it look nice, but it's gonna be kind of tricky because we have to slide the tubing onto it and then heat it up, but we don't have a lot of room, you know?
I see that.
So what we'll do here is we'll take this ground, the black wire, cut the black wire. So yeah, what I like doing is just cutting things at different lengths. So we'll twist it just so it's one thing. So this will be the longest point, so all the other wires will be shorter. That way when we wire it up, the solder points won't be in the same place, which means the wire, it won't have a big blob of wires.
Right, right, yeah.
I'm gonna take this, twist it as much as I can. It's gonna take a little bit more heat because there's more wire mass. That should be enough. Well, I just gotta continue putting these wires. I basically just have to follow the pinout that I wrote down and solder them together. Hey, we extended the cord. Now we can play Mega Man 2 Beatbox Edition.
Fantastic.
Let's see if I remember not only the game, but the music. Okay, so right here it would go ding doon 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 ding, ding doon 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 ding, ding ding doon 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 ding, ding doon 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 ding, ding doon 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 doon. Dun, dun, and you just give a head. Dun, 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 dun.
Ben, that's amazing.
Down, 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 down.
Ben, I'm ready to play some Castlevania here. Are you ready? I'm ready for musical
was this
styles.
a save? Oh, that was a,
Yeah, no, that was just the promo.
Go ahead
that
and
was the
start it.
Demo. Here we go. And I'm going to get started now. That's pretty good.
All right.
That's impressive.
Yeah, it seems to be working now, right?
I think it's working great, yeah.
Cool. Well, that was a lot of fun, looking inside of the NES Classic, playing it, and then extending the controller cable. So David, where can people find you online?
Well, I host a show called the Technophiles podcast on iTunes and Google Play, and we also do a small show on YouTube called the Technophiles Newscast.
Oh, that makes sense. So look for David online at those locations. We'll provide links below. Well, that's all the time we have for today. Be sure to go to element14.com/TBHS to read about other upcoming episodes, builds, and special events. We'll hack you next time. Let's go play some Nintendo.
Now you gotta just make a pair of binoculars that connect to the controller for me. Even me, I am the danger. Oh, Ben, you're fine. I can hold this all day long.
They used red for ground? Oh, no. Calm down. Okay. Red for power. Okay.
All right. I was like, even I know that's weird.
If you go to Slytherin, does that mean you're evil?
I know, it really has to give you a complex if you go to Slytherin, right?
Yeah, it's like, I'm Slytherin.
Slytherin,
I'm evil.
Like, what if you didn't want it, but you're like, oh, cool.
I'm not that into the
So I
Dark
think
Lord.
that technically they're not evil. I think they're just like really ambitious, and for some reason in the Harry Potter world, ambitious equals evil.
You are a Satanist. No, I'm not.
I don't think so. I mean, if you insist.
I mean, that could be a film theory. It's like, did Dumbledore turn them evil? What does that hat do the rest of the year?
What, the sorting hat?
Yeah.
Yeah, I think it just sits there and watches movies.
He's probably Facebook friends with Mario's hat.
It's working. It's working.
Best start believing in the NES Classic. You have it.
And then what? The alternative is if it can't do it, then we just lose the thing and whatever.
Yeah.
That was a sentence with a lot of pronouns. But they did say that, oh, we're rolling, never mind.
You could almost make this into like a little portable unit. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.